Good day, everyone. I am Shelly Gail Cagaanan, and along with me is Ernest Jacob GULAY, and we will report about our output in our learning activity 2 for IE16. So this is the overall flow of our video. The part 1, the background introduction, will be presented by me up until the interpretation of the parameters. The rest will be explained by my partner. So as for the background introduction, so the study focuses on investigating the relationship of the economic factor as a predictor of food choice towards Mang Inasal on the senior high school students. So the researchers come up with this study because of the actual or real life phenomenon Mang Inasal, wherein consumers or customers considers repetition of food choice in the business venture despite Mang Inasal having a longer time arrival for the food. There are crowdedness in the area, and sometimes the food is unavailable. So in the actual study, there is actually one independent variable and 3 dependent variable. So the dependent variables are named economic factor, hunger satisfaction, and cultural factors. So the economic factors refer to it in layman's term as pagkasulit. And for the cultural factors, in layman's term is pagka-Pinoy. And as for the hunger satisfaction, in layman's term is kind of makabusog. So that is what this study is all about. But since in this activity, we will use simple linear regression, so we'll just assume that this study focuses only to one dependent variable and one independent variable. So the independent variable is the food choice and the dependent variable is the economic factor. So as for the data gathering, a random sampling method is implemented and the participants are 322 individuals as determined by Cochrane sampling determination. So the 322 is got from SPSS, but in the actual data gathering, the researchers were able to gather 386 participants all in all. So the participants in the study are identified as the senior high school students of XUSHS on the main campus. So it means that it only covers the strands ABM, UMS, GAS, and STEM, and excluding those on the TVL track that are located in the Uptown campus. So this study is actually a combination of a qualitative and quantitative study wherein the qualitative values are interpreted in a quantitative manner. So we use dummy variables or a Likert scale in this. So 1 stands for strongly disagree, 2 for disagree, 3 for agree, and 4 for strongly agree. So this is how we got the values. So what we got in the actual questionnaire, there are actually 5 questions allotted per variable. So we just interpreted it using those dummy variables and get the mean on each. So the mean is then used in this portion wherein we get the values that we will interpret later on. So after that, we have to click on the labels, confidence interval, and click on the cell that we want the output to be placed, and click on residual plots and the normal probability plots. So this will then be the result. So we will use these numbers and this graph that later on, and this is how we got our scatter plot and the model of our regression line. These are all just found in Excel. And this is our residual plot and normal probability plot. So this is the scatter plot and the model of the regression line. So y is equals to 0.661x plus 1.1449, wherein 0.661 is the slope and 1.1449 is the intercept. So as for the interpretation, there is a 0.661 change towards their choice to choose manginasal due to its economic factor. And as for the intercept, regardless of the movement of the independent variable, the food choice, participant will strongly disagree. So the disagree is gathered from the value 1.1449, because the value 1.1449 will then go interpreted using those dummy variables or the Likert scale. So 1.1449 is close to the value 1, wherein 1 stands for strongly disagree. So even if there is a relationship, because the value is 0.33, it stands for weak relationship between the variables, even though there is a relationship, the participants will have the tendency to strongly disagree. So it is because of some other factors. So let's observe what happens in the real life. So for the real life events, what you see in Manginasal, or the customers that you will see in Manginasal, are those ages 20s, 30s, 40s, or 50s. We rarely get to see students who would dine in Manginasal. So in this study, it would have been better if the actual participants are those ages that were mentioned, rather than those senior high school students.
One of the most important mathematical tools in statistics is standard error. It is because standard errors can help us determine if there is a linear relationship between the variables. It can also help us construct the confidence interval. Our level of confidence is 95%. Therefore, we can say that we may be 95% confident that the value of the true slope of the regression line is somewhere between 0.5686 and 0.7535. Since the interval excludes 0, we can say that there is a linear relationship between food choice and economic factor. To confirm this, we must perform hypothesis testing. As we all know, hypothesis testing is very important. We conduct hypothesis testing so that we can see if there is a relationship between the variables. The null hypothesis, HO or B1 is equal to 0, means that there is no linear relationship between the variables. The alternative hypothesis, H1 or B1 is not equal to 0, means that there is a linear relationship between the variables. As you can see, the p-value is 1.61286 exponent negative 36 or 0.00, and it is lower than the significance level alpha, which is 0.05, having a t-stat value of 14.06 and f-stat value of 197.72. Therefore, we will reject the null hypothesis, implying that there is a linear relationship between food choice and economic factor. As shown in the summary output, only 33.99% of the variation y is explained by x. Since the r-squared of the study is 33.99% and it is below 50%, the predictions of the data may be poor. As we can see in the data from the residual plot, from 1 to 2.5 the data points are scattered, and from 2.5 to 4 we can observe that there is a pattern that is like a shape of the cone, and it means that it is heteroscedastic. Therefore, the residual plot has inconsistencies. This can be due to the factors that affect the spread of the data points in the residual plot. Since the points 2.5 to 4 of the residual plot is heteroscedastic, we cannot use this model for prediction. In the normal probability plot, we can see that the errors are not normally distributed. Therefore, we cannot also use the normal probability plot for prediction. Therefore, both models are inadequate to use for prediction. Due to our residual plot representing heteroscedasticity and the errors in our normal probability plot are not normally distributed, we should go back to the first step in specifying a statistical model. Also, we should go back to our gathered data and find factors or uncertainties that affected our data. If our residual analysis, especially our residual plot, is not heteroscedastic and our errors in the normal probability plot are normally distributed, then we can use the models for prediction and determine the prediction interval.